The breadboard is got to be the #1 prototyping tool for anyone doing electronics. Now, when you first look at a breadboard, it looks like there's a lot going on, and it can be quite confusing at first how you make connections on a breadboard, because there's so many pins and so many different types of configurations, but ultimately it isn't so bad, and whenever you get used to it, it actually becomes very natural. So what I've done is drawn out what a breadboard looks like on the inside, and I have also magnified it a little bit. So you can see here that there are rows of 5 pins that go the whole way down, and there's a second row of those 5 here. Alright, and each row of 5 is electrically connected to the one beside it. And we can test this or prove this with a multimeter and some resistors or something. So sometimes I like to just put one end of a resistor in because it's the right size. Basically it's just a wire, but you can see that alright, so this tool, whenever there's electrical continuity, it beeps. Alright, and if we check, we see there is continuity, or there's electrical connection between those 2 points, and I can put the resistor in any one of these, only in this row. If I move it to the next row, there's no connection. Okay? So why have 5 of them? Well, I mean, 5 is, I don't think there's really any science to it as to why it's 5. It's just become a standard. But the reason why you might want to have more than one is oftentimes you'll have several wires going to the same spot. So let's say you have a integrated circuit put in here, and you can see there's this nice little slot going down the center for them. Now at this point, anything that I put into this row right here will be connected to that pin on the IC. IC is integrated circuit, and so I could connect the resistor to that pin by putting it in any one of the 5 on that row. If I put it beside it into the next row, it won't connect. So I could put that guy in there like that. Now you'll notice I have this with the 4 legs on one side and the 4 legs on the other, and that's fine because this is this little gap here. It's called the IC slot, I guess. And even though these 5 in a row are connected and these 5 in a row are connected, the 2 rows themselves are separated from each other. So let's see what I mean by that. So we showed before that something like this are connected, but if I move this, it's kind of in the same row, but it's across, there's this gap separating it. There's no continuity. And the reason for that is if there was a continuity and it connected, then whenever I put this chip in here, it would short these neighboring wires, or it would short these 2 pins across from each other to each other, and we don't want that. So that's why this center line acts as a break between the 2 sides. Why don't I build a simple circuit on the breadboard so we can see how this works. I'm going to use this handy dandy battery. It's a phone charger, so it puts out 5 volts, but I use it for electronics all the time. And so I'm just going to grab from my assortment a green LED and a 1K resistor. Yeah, that's fine. Alright, so I think the first thing I'm going to do is put the LED in, and I'm going to put it in so that the 2 legs are in separate rows. If I put them in the same row, then they're going to be they're actually electrically touching each other, and that's no good. So they've got to be in different rows. And well, I'm going to move it more in the middle so we have room to work with. And then I'm going to take the resistor and attach it into the same row as the positive side of the LED, the anode. I know I haven't talked about how LEDs work, but this is really just to demonstrate how the circuit wiring goes. On this particular guy, blue is positive, green is negative. That's just what I have plugged in. And so I'm going to connect the positive with the battery in the same row with this lead of the resistor. And then the negative over here, we should have the light. Yay. Okay. So you can see how it's working. And if I move the positive into there, right beside it, it's disconnected because the connections don't go across like this. All the connections are up and down like that. So it could be in any one of these 5. Any one of them. Okay, now there's one part I haven't talked about yet, and that is these rails, we call them, on the top and the bottom. These are power rails, and in a simple circuit like this, I really didn't need them, but when you start having more complex circuits where 5 different devices might need power, this is up here so that it's always available to run power up and down to your devices. So I'll show you what I mean. Let's disconnect this. I'll keep the LED kind of where it is, but instead, you know what, I'll move it down. That's fine. I'm going to have the resistor connect to the rail closest to this red line. You can see there's 2 rails. This one's marked with a plus sign. This one's marked with a negative sign. And the rails work a little bit differently. So even though there's a gap between this group of 5 and this group of 5 here, they are actually connected. Let me prove that. I'll test that. So first thing is, in the same group of 5, in the same rail, they're connected. Right. In different rails, one of them is in the negative strip, the other's in the positive strip, they're not connected. Right, because we don't want the negative and positive touching each other. Across this little gap, in the same rail, they're both in the red rail, it is connected. In fact, you can go the whole way across. So what that means is you could connect your power on one side. I could put my battery in all the way over here, and it will apply power the whole way across, which is nice. So Now in order to complete this circuit, I am going to need to grab a little jumper wire and this is 22 gauge wire, I believe, that will fit into a breadboard. I could be wrong on that. Whoops. There goes that wire. I got another one. And so I'm going to connect this to any one of the pins of the negative rail. So positive through the LED to negative, and it lights up. Great. And I can take that and move it over to any one of the other ones. Now what I should note is that this negative rail and this negative rail are usually not connected by default. Sometimes it's helpful to, before you start breadboarding anything, you know, take and connect the red to the red so that you can go to the top for power or go to the bottom for power if you wish. Or you could do that with the grounds too. You could connect the ground to ground. If I do that, now I could go to light up the LED. I could come down and give it ground on this bottom ground rail, or I could come up and give it ground from the top ground rail. Without that wire, it won't go to the top though. So the best way to get good with using a breadboard is really just practice. It will eventually become second nature, and using a breadboard will also get you more familiar with just circuit layout in general. But it sure beats twisting wires together, let me tell you that. Well, I hope you found this video useful and that you learned something. Thanks for watching. Please like or subscribe if you did find it useful. Well, bye.